colder than liquid nitrogen, minus 367 degrees Fahrenheit. It was also dark. It would have remained a very gloomy place, full of gas, but without galaxies, stars, or planets, if it hadn't been for one thing. The baby universe wasn't born perfect. Carlos Frank has created an amazing 3D simulation of how the early universe evolved. It shows that when the universe emerged from the Big Bang, it was uneven.
Little cracks appeared, which were very, very, very tiny, very, very small. And there was this rush in the face of the baby universe that later developed into the patterns that we see in the galaxies today.
Without these cracks, the universe would have been a very dull place. The first clues as to how these cracks developed into galaxies and stars came when other scientists started to examine the Big Bang radiation first discovered by Penzias and Wilson.
So what Penzias and Wilson saw was this radiation was, as far as they can tell, uniform. What cosmologists then did for the next 25 years was work very hard to try to find tiny variations.
And find them they did, using WMAP, a space probe designed to detect and analyze in detail variations in the background microwave radiation. Launched in 2001, the $150 million probe was fitted with some of the most sensitive instruments ever carried into space. Our eyes detect only visible starlight, but WMAP can tune into the invisible microwave radiation. Once in orbit around the sun, it picked up the faint radiation that has been rippling around the universe since the dawn of time.
So when we look at the cosmic background radiation, we're looking at this radiation that's been streaming towards us since 500,000 years after the Big Bang.
Initially, the microwave universe looked very dull and seemed to be the same everywhere. But when WMAP turned up contrast, the results were spectacular. The baby universe wasn't smooth and boring at all. It was full of fluctuations.
These tiny fluctuations tell us what the variations in density, how much stuff there is, and how it varies from place to place. These denser regions are going to collapse to form clusters of galaxies and superclusters and galaxies themselves. These low-density regions, these will grow and become the empty regions between galaxies. So this picture really is our connection between the universe when it was a baby, 500,000 years old, to the universe today, 13.7 billion years old.
These tiny imperfections in the fledgling universe would become galaxies and stars.
And this is one of the most amazing propositions in physics. The idea that galaxies like a Milky Way that contain 100 million stars once began life as a tiny little crack in the fabric of the universe.
The material in these cracks was filled with swirling clouds of hydrogen atoms. The voids between the clouds grew bigger and bigger. The gas clouds got denser and hotter. Gravity pulled the gas clouds together on filaments, like beads on threads of a web, cosmic web. Where the giant filaments formed large globs, stars and galaxies would grow.
As the universe evolved, gases were able to condense into clouds, which collapse to form stars. The stars settle into a rotating disk that was later to become a spiral galaxy like the Milky Way.
Over millions of years, the hydrogen atoms clumped together and heated up. The atoms began fusing and releasing energy, and the gas clouds started to burn brightly. Eventually, a star was born. All over the universe, millions of stars ignited for the first time.
The appearance of the first stars would have been a truly spectacular event. Had we been there, we would have really seen fireworks. Individual, enormous flashes of light generated as the stars are born and burn themselves out.
The universe has expanded many trillions of times its original size. was full of newborn stars made of hydrogen and helium. These young stars were nothing like our own sun. They were very unstable. But it was their instability that would make the universe a more interesting place, because deep inside each new star, something amazing was happening. They were creating new elements. The idea that stars build atoms came from the British astrophysicist Sir Fred Hoyle, one of the greatest astronomers of the 20th century. Hoyle didn't believe that the universe began in a single explosion. In fact, he coined the name Big Bang as a term of derision. Hoyle wanted to know where the elements heavier than hydrogen and helium came from. He figured out that stars acted like nuclear reactors, working a bit like a hydrogen bomb in slow motion. But many billion times more powerful, and their nuclear waste was new elements. But it would take years before scientists were able to confirm his theory by analyzing the light from stars. Each element emits a light at a particular frequency when heated up. Imagine a sodium street lamp. It emits light of a yellow color specific to sodium. It's the same with stars. Take our sun. If you break the light down into a spectrum, you can see lines like a barcode corresponding to the elements. Each element has specific colors, helping scientists identify elements like hydrogen, which emits mainly red light.
We are go for main engine.
In 1990, NASA launched the Hubble Space Telescope to unravel some of the mysteries of our early universe.
And liftoff of the Space Shuttle Discovery with the Hubble Space Telescope, our window on the universe.
Hubble promised scientists unprecedented views of the young universe. It would be able to look back through space and time and examine early stars to discover if they were making new elements. But the dream soon turned into the worst nightmare. After it was launched, they discovered that Hubble's mirror was distorted. It saw everything out of focus. It needed corrective lenses. And the only way to fix it was to send up another space shuttle. One of the repairmen was astronaut Jeff Hoffman.
We were working with a $2 billion telescope, and the last thing we wanted was to break something and leave it worse off than when we got up there.
First, the crew of the rescue mission had to capture the crippled telescope. Then execute a repair mission unprecedented in the history of spaceflight. First, they had to open the access doors on the side of the telescope.
The one thing about working on Hubble that is very different from working on a car is you look over your shoulder and there you are in space, and the Earth is going by below you, the stars above you.
The astronauts had to carry out fine, detailed work in the most difficult conditions.
When you're working in a spacesuit, your hands are encumbered by thick, stiff gloves. It's sort of like working in ski mittens, and it was quite a challenge.
All went well until Hoffman attempted to close the huge access doors.
I just had to close up the doors, and when I went to close them, they wouldn't close properly. The doors were somewhat warped, and it took a while for it to sink in. This was very serious. If you can't get the doors closed, you lose the telescope.
Using improvised tools, Jeff and a colleague were finally able to close the doors. It took the team 5 days to repair the stricken telescope. Cosmologists around the world held their collective breath. They waited to see if the most expensive telescope ever built would deliver what its designers originally promised.
I well remember New Year's Eve